This is the Lockpicking Lawyer, and today we're going to do something really fun. Now this lock is an ABUS Titalium model 9050. It's the exact same lock that I featured in video number 589, and in that video I picked the lock open and then I took it apart to show you what was inside. But today I'm going to attempt to crush this padlock with my bare hands, and I'm going to do that with the help of some gallium. Now gallium's a really interesting metal with lots of cool properties. Probably my favorite is its really low melting temperature. It's about 85 degrees Fahrenheit or 30 degrees Celsius. What that means is that this can be a solid at room temperature, but then if you put it in your hands, your body heat will melt it. Now I've already melted this in advance, so you can see we have a liquid right here. Now there are lots of uses for this in industry, mostly for semiconductors, but one really cool property of this is that if you put it in contact with most aluminum alloys, it will infuse into the aluminum microcrystalline grain and prevent the metal crystals from forming strong bonds with each other. That means that if I put this gallium on this lock and give it enough time, this lock will become so weak that I should be able to break it apart in my bare hands. So that's what we're going to do right now. I'm going to get some paper and put it under this lock, so hopefully I won't make too much of a mess. And then I'm going to put this gallium right on the lock and then scratch up the aluminum surface so the gallium can come into direct contact with the aluminum itself. Now aluminum, if you just leave it out in the atmosphere, will very quickly form a boundary layer of aluminum oxide, which will prevent this reaction from taking place. So after I put some of this gallium on the lock, I'm going to take one of my lock picks and try to scratch this surface up a little bit so the gallium and aluminum can form an alloy together. Okay, that is more than enough gallium. Now let's get a lock pick and scratch up the surface and hopefully spread this gallium around a little bit. Now usually gallium will wet most materials, meaning it will stick to it. But that doesn't seem to be happening here with this aluminum. Hopefully that'll change as it starts to react with it. Let me get something that'll scratch that just a little bit better. Got a little razor blade here. Okay, this gallium isn't really staying in one spot, or it's not spreading out as I hoped it would, but that shouldn't be too much of a problem for us. I've got this scraped up pretty good, and with the way gallium infuses into aluminum, it shouldn't matter exactly where we put it on the lock, because even if I put it right here on the corner, eventually that gallium will infuse throughout the entire lock. Make one final attempt to spread this out, and it doesn't seem to be working, so maybe I'll just leave it alone for a while. Okay, this is something that's going to take at least a few hours, so now that I have this scratched up and the gallium is on this, we're going to cut the video and I'm going to come back in just a little while. Okay, it's about an hour later and you can see that the gallium has already made a pretty significant impact on this lock. You can see that it has migrated from where I left it in the middle of the lock over to the left here, and it seems to have eaten away the top layer of aluminum here. So let me try to push it back toward the center of the lock because I have a funny feeling this is about to fall off. I want to make sure the gallium spends all of its time eating away at this lock. Well, maybe that's as good as we're going to be able to get. There we go. Okay, we seem to have a lot more surface area of contact between the aluminum and the gallium now, and we have this mixture of aluminum and gallium right here. I'm going to get something and we're going to try a little experiment with that. Okay, I just got this little vial of water and I'm about to show you another interesting property of gallium. Now, scientists are actually experimenting with the alloy that you see right here, the mixture of aluminum and gallium, for use in alternative fuel cars. What happens is when you mix this aluminum gallium alloy with water, it actually breaks the water down. The aluminum reacts with the water. See if I can get a little bit of this. And it creates aluminum oxide and hydrogen. So let's see what happens when we put this in the water here. You can see a lot of hydrogen is bubbling up out of there, and this actually doesn't destroy the gallium at all. You can recover the gallium after this reaction is done, which is one of the reasons why they're experimenting with this as an alternate fuel. Interesting little side note, but not what we're dealing with today. Right now, I just want to see this lock get destroyed. So let me spread this out again, and then we'll give this a little bit more time. It's about 10 minutes later, and I wanted to show you a bizarre phenomenon that's occurring on the face of this lock. And that is that the gallium seems to be traveling around the lock underneath the surface. And let me just show you what I'm talking about. You can see it's almost like there is a liquid underneath the surface. And if we just scratch it a little bit, you can see that gallium aluminum alloy underneath. We're also reaching the point where this gallium is dripping off the padlock. Let me see if I can pull some of this off from the side. And if I just put it anywhere on the face, it rapidly travels back to where it came from. So I think I used probably way too much gallium here, but it's traveling in some places under the surface of the lock, like right up here. If I break it up, you can see all that gallium just underneath the surface. It's a really bizarre thing. I'm not sure I've ever seen anything quite like it. Even all the way down here toward the bottom of the lock, we're seeing the same thing. So let me give it a little bit more time and we'll come back to it when we have more results. It's about 4 hours later and I've taken a couple of precautions. First, I have moved the lock onto a large piece of craft paper, and second, I decided to wear some rubber gloves, not because there's anything dangerous about gallium, but because I don't want to take the risk of contaminating anything else in my work area. So let's take a look at this lock. As you can see, the front of it looks pretty gnarly, but there isn't much in the way of liquid left. It is a little bit slippery, and I suppose there is some liquid gallium, but hardly any. If we move around to the side, you can see this rot has infested the side, looks like the bottom, and definitely the bottom or the back of this lock as well. So I don't know whether the gallium simply seeped around the edges underneath the surface or it infused completely through the lock body, but let's take a look. Whoa, I just had a little piece of that lock break off. Okay, clearly it has it's infused well into the lock body. So let's see if we can break this apart. Let's start by trying to get little chunks off. And I guess right here was the exception. Let me get a small screwdriver and see what happens with this. Wow, I can see I can see the metal breaking very, very easily. And yeah, this metal is very, very weak. It's pretty much just crumbling without a whole lot of force. This is pretty incredible what this gallium has done to the aluminum. Let's see if we can break enough of this off that the lock will actually open up. Okay, not quite as soft as it could be. I'm debating whether or not we should give this more time or maybe just try a different way of breaking it open. I suspect if we hit it with something, it would open relatively easily. Let me grab this piece of wire. See if we can break the bottom. Whoa, we broke the bottom really easily here. I guess it just depends on where in the lock we strike that we find the weak points. Wonder what happens if I just pull on the shackle or try to twist it. No, it's not coming apart quite that easily. Oh, there we go. Wow, a big chunk of this. Whoa, look at this. I just peeled the whole lock apart. And how's that for a cutaway on what a lock looks like on the inside? You can see all the parts pretty darn clearly. Wonder if there's anything in that core that's aluminum. Hopefully I'll be able to salvage that at least. And the rest of this, wow, this is just breaking apart very, very easily. I've never tried eating away eating away aluminum with gallium or compromising aluminum with gallium, but clearly you can see that this is this lock is just destroyed. If I had hit this with a hammer in the very beginning, I suspect this just would have shattered. So, titanium versus gallium. I think you can see which was the winner here. This lock is well and truly destroyed. Of course, this is not a practical way of opening a lock. Anything that requires 5 or 6 hours of soaking clearly isn't something you would use to open a door. Nevertheless, I think it's a lot of fun. So, that's all I have for you today. If you do have any questions or comments about this, please put them below. If you like this video and would like to see more like it, please subscribe. And as always, have a nice day. Thank you.